Hi everyone. In this video, we're going to learn how to solve the indices equation and which involve the concept of quadratic equation. All right. So I have an example here. 2 multiplied by 2 power of 2x minus 5 power of x plus 2 equals to 0. Now we can convert this into the quadratic form, where I will just write down, okay, the coefficient of 2, just write down, and you've got a 2 power of 2x can be written as a 2 power of x and power of 2 minus 5 multiplied by 2 power of x plus 2 equals to 0. I hope that you can see that this is in the quadratic form, where if you just substitute a as a 2 power of x, then I will rewrite this equation in terms of a. I will have 2a squared minus 5a plus 2 equals to 0. So can you see that the 2 power of x has been substituted as a? So you can see that very clearly this is a quadratic equation. We try to use the knowledge to solve the quadratic equation. Find a first, then we will change the a back to the 2 power of x. From there, we solve for the x. So if you have a 2a squared minus 5a plus 2 equals to 0, this is already in the general form where you can directly try to factorize. Factorize, you got a 2a multiplied by a, 2 multiplied by 1, negative, negative. Alright, try to expand it back, check whether your factorization is correct. So 2a squared minus 4a minus 1a, you got negative 5a. Negative 1 multiplied by negative 2, you got positive 2. So what you have factorized is correct. Now you can solve for the a, where the first a is 1 over 2. Second a will be the 2. Alright, so now we're not interested on a, but we're interested on x. Try to change back your a back to the 2 power of x. 1 over 2 can be written as a 2 power of negative 1. So now you got an equation, indices equation, where the base at both sides are the same, and now you can compare the x to solve for the x. You got x equals to 1. And for the second solution from the quadratic equation, you just substitute back the a as a 2 power of x equals to 2. So 2 can be actually be written as a 2 power of 1. So the same thing happened because we have a same base at both sides. Now to solve for the x, we just can compare both sides and you got x equals to 1. So conclusion, you got two answers for this question. Alright, one is x equals to negative 1, the other one is x equals to 1. Both are satisfying this equation. For this question, we need to do some adjustment because we still can't see this can be written in the general form of the quadratic equation. So firstly, I will just separate this 2 power of 2x plus 1 separate into the 2 power of 2x multiplied by 2 power of 1 using the laws of indices, plus 16, I just maintain it at 16, equals to 33, 2 power of x. Alright, and we're trying to change this into the quadratic form. We would like to move every term with the 2 power of x all constant to the left side, and we leave the right hand side to be 0. So now I'm going to do it, but before I move everything to the left side, I see my first term can be simplified into 2 multiplied by 2 power of x power of 2. 2 power of 1 I move to the front, and the 2 power of 2x I'm going to write it as a 2 power of x and power of 2, so that later on you will see actually this is a quadratic form. And I move the right hand side term with the 2 power of x to the left side. I got negative 33, 2 power of x plus 16 equals to 0. So as you see that now my equation become general form of the quadratic equation. where later on I'm going to substitute the a as the 2 power of x so that you can see clearly it is a quadratic equation. And we can use a quadratic equation, solving quadratic equation to solve for this equation. So now you got 2a squared minus 33a plus 16. So I would like to factorize as if that we are solving for the quadratic equation first. You got the 2a multiplied by a, and 16 I'll put it here because 16 multiplied by 2 you got 32. 32 minus 1a you got negative 33. So I put a negative over here. Expand back, check your factorization. I got 2a squared. 2a multiplied by negative 16, I got negative 32. Minus negative a, I got negative 33a. Negative 1 multiplied by negative 16, I got positive 16. Okay, so now you got a two solution form the quadratic equation. You got a equals to 1 over 2, and the other one is a equals to 16. So now we actually need to substitute back the a with the 2 power of x. So a back to the 2 power of x. 1 over 2, convert it back to the 2 power of negative 1. Compare the power at both sides. I got my f equals to negative 1. And for the other answer, for the a equals to 16, I will put back the a as the 2 power of x. And the 16, I change it into the base of 2, where this is a 2 power of 4. Then finally, I got my x equals to 4 by comparing the power at both sides. Finally, I would need to write down my answers. That is x equals to negative 1 and x equals to 4. Here is my third example on solving indices equation using the quadratic equation concept. So here I got a 2 power of 2x plus 1. Alright, now we need to expand it first. We got the 2 power of 2x plus 2 plus 3 multiplied by 2 power of x equal. If you can see that fast, actually you can move the 1 to the left side and leave the 0 at the right side. If you already can see that it is going to use the quadratic concept to solve for this equation. You can directly move everything to the left side. So now I try to separate the first term into 2 power of x squared, where this is the 2 power of 2x. 2 power of 2x can be written as 2 power of x and then square. And the constant, I always like a coefficient, I always prefer to put them at the front of the 2 power of x. I got my 2 power of 2, that is my 4. So this first term, I have converted into the quadratic form, that is my 4. If I substitute the 2 power of x as a, I got 4a squared plus 3 multiplied by 2 power of x minus 1 equals to 0. If you substitute the a now with the 2 power of x by the a, you will see that your equation become like this. So it is exactly quadratic form. Now I'm going to use the factorization to solve for the a first. I got my 4a, 1, 1. To get the positive 3a, this has to be positive and this has to be negative. Let's check. 4a multiplied by a, I got 4a squared. 4a multiplied by 1, 4a minus a, you got 3a. And negative 1 multiplied by 1, you got negative 1. Alright, now you have a equals to 1 over 4. The other answer is a equals to negative 1. So now substitute back the a to the 2 power of x. 2 power of x is your a, and 1 over 4, I'm going to change the 1 over 4 in the index number where the base is 2. So this is a 2. 4 is 2 square, and 4 actually is at the denominator. Now I bring it back, I bring it up, I got to put negative over here. Because 1 over 4 is equivalent to 2 power of negative 2. Then now compare the power at both sides. I got x equals to negative 2. And for this a equals to negative 1, you got 2x, replace the a, and equals to -1. And I would say that this has no solution. Why? Because 2 power of x is an exponential function, and the exponential function, whatever f is it, it won't take the negative number. So we just ignore this set of solution. Okay, so our final answer is just x equals to -2. Alright, so thank you for watching. For this question, we need to do some adjustments so that we can see that this can be converted into the quadratic equation. For this first term, I'm going to separate it into the 3 power of 2x multiplied by 3 power of 1. Second term, I'll split it into the 3 power of x multiplied by 3 power of 3. And for the right side, just copy down first. And after that, I will convert this, not convert, I will rewrite this in a form of a 3, where the coefficient I will just put at the front, and multiply by 3 power of x squared, where the 3 power of 2x is written in the form of 3 power of x, then squared, minus 27 multiplied by 3 power of x plus 3 power of 3 is 27. And move this term to the left side, I got negative 3 power of x. Move the negative 9 to the left side, I got positive 9 equals to 0. Alright, so if you can see that the center, the two terms at the middle here can be simplified. You can take this as your apple, negative 27 apple, minus 1 apple, you get negative 28 apple. Simplify in this way. And after that, you can see that this is already in the quadratic equation. Alright, it's a quadratic form. Then after that, it's a quadratic form. To be more obvious, you can substitute the a as 3 power of x. Then rewrite the 3 power of x in terms of a. You get a 3a squared minus 28a plus 9 equals to 0. So this now is exactly quadratic equation. You can actually solve the quadratic equation, solve for the a, okay, by using factorization. Firstly, I will just put the 3a, and then 9 over here, so that I got negative 28. You got a 3a negative, 3a multiplied by negative 9, you got negative 27a, minus 1a, should be negative over here, negative 1a, then you got negative 28a. Let's check whether it is correct. 3a multiplied by a, 3a squared, negative 27 minus 1, you get negative 28a. Positive, negative 1 multiplied by negative 9, you got positive 9. So now you got a equals to 1 over 3. The other set of answer is a equals to 9. Put back the a as a 3 power of x, and 1 over 3 change back into the 3 power of negative 1. You will see that now you can find the x by comparing the power, which is x equals to negative 1. And for the other side, you also will put back the a as a 3 power of x, and a and 9 change it into the 3 square. Comparing the power, you got x equals to 2. Finally, you got x equals to negative 1 and 2. Alright, thank you for watching.